Hello, my name is Nick, and I am a student studying computer science at Wayne State University, and I'm minoring in statistics, hence me taking this class. And I'm here to talk about if there is a significant difference in crime rates of Republican governed states and Democrat governed states. I've been seeing a lot of articles lately comparing cities and states that have a high crime rate, kind of blaming it on different political parties. So I'm here to put that to the test. My data comes straight from the FBI. They have a crime data explorer. I'll leave the link down below if you want to check it out. There's a lot of cool data there, and analysis is just waiting to happen. I am leveraging violent crime data and property crime data from 1979 to 2020. But I will be focusing more on the violent crime data. More on that later. They're going to be similar either way. So violent crime data includes homicide, rape, robbery, and aggravated assault. Property crime includes burglary, larceny, and motor vehicle theft. But this data is incomplete for the analysis I want to do, so I have to merge state government data into the data based on year. So basically I grabbed governor data from websites. Most state websites have a kind of a list of the governors, and you can cross-check which political party they were from. And I also used Wikipedia, so just for full disclosure. There's a couple things to get out of the way. How did I deal with elections that kind of fell on odd months? So whether a governor only served 3 months and then there was an election, or a governor served 6 months and then there was an election, or a governor died or resigned or something. So basically the way I did it, and you can disagree or agree, if a governor served 6 months or more in their governorship, then that year belongs to them. If they served less than that, whether it's 5 months, whether it's 3 months, then it goes to the new elected governor. Also, I eliminated all independent and third-party governors. There weren't many, but there were a couple. I would have left it in, but running analysis on like 8 governors over 30, 40 years, the statistics don't work well. To account for the different population sizes, for instance, California and Wyoming having vastly different population sizes and that being able to skew the data, what I did was I took the crime number and then I divided it by the population to give a crime per person number that we are going to be analyzing. Our plan is pretty simple. We're going to have normally distributed data, and we're going to run a 2-sample t-test on it comparing Republican and Democrats' crime rate numbers. Then we're going to report the p-value. It's that simple. But first, we have to check if it is normally distributed. To check, I ran the Shapiro-Wilks normality test to check for normality, and I reported the p-values for each year. And it turns out some of our data falls below the p-value, so some of our data isn't normally distributed. I don't necessarily want to take any of the data out, so we're going to use a different test. We're going to make a whole new plan. Step 1, we're going to make a bunch of box plots. How many exactly? Well, around like 40, because that's how many years we have. From the box plots, we can see that the data is pretty similar between Republicans and Democrats. But we can't necessarily tell from a box plot. So we're going to do a Wilcoxon-Rank sum test where the mu is equal to 0. So next we plotted the p-values that we got from all the Wilcoxon tests for all the years, and it's on this plot. And you'll notice that all the p-values are a little high. There's a couple outliers that are pretty low, but I don't think that there's enough evidence that it's low to reject the null hypothesis. The null hypothesis just means there's no significant difference in the medians between red and blue states. And the alternative hypothesis is that there just is a significant difference. Most of the p-values scored above our significance level of 0.05, meaning that we can't reject the null hypothesis. So this means there's no significant difference in crime rates between blue and red states. But wait, that's not all. We ran 4 regression models. Using the violent crime data set, we did crime per person with year by state. Using the crime data set, we also did crime per person with year, state party, and state. The difference in between the two is that political party is not present in one of them. And then we did the same for the property crime data. For the regression model, we got a pretty high R-squared and a pretty low p-value, meaning that it mostly fits the data. So is that it? The model, we have the model, it fits good. Is that all we needed to know? No. So what we wanted to do, we want to compare whether the party affiliation matters when making the model. If it doesn't affect the p-value or R-squared, then it's not a significant predictor. And of course, we found that it made almost no difference. Look at the difference in between these graphs. There is almost 0. So this means that affiliation is not a significant factor because it did not change the p-value even going back to like 16 decimal points. So let's summarize and conclude everything that we learned today. Statistically, we can say that state governors do not have a significant effect on the crime rate. So we did our analysis. Where can we go from here? What do we even do with this information? Well, I think an interesting analysis that needs to be run, doing this type of analysis on city or local governments based on mayor, maybe even police chiefs, because they really are what makes the policies that go into policing these crimes. Not that state government doesn't make policies, but local government might have a little more control. But even if we did that analysis, I would expect that we get similar results. And the only reason that I didn't do that is that the data was too scattered to collect by the time of this, this analysis was due. This is a part I can't necessarily prove with statistics. With this data, I would like to see people less demonize states, whether it be red or blue, and more look at the systemic problems within these states, the systemic problems within the system. Whether you look at low education or whether you look at just someone not being able to provide for their family. There are systemic problems at play, and if you look at these smaller problems, I don't necessarily know which ones, but those would be a good place to start. I would predict that we would get actual significant data. Next, I just want to wrap up by saying if there's any questions or concerns about my analysis or my data, I would be happy to talk to you about it. You can comment down below or send me a direct email. All my data and analysis and code will be on GitHub. I will link everything that you need to know down below. And lastly, I know this was kind of a long video. I really appreciate you watching this and taking the time out of your day, even though we kind of have to. I will also want to give a big thanks to Professor Shinky. If I'm pronouncing that wrong, I'm very sorry. We didn't meet very much, so I never got to hear you pronounce your name. But thank you again for such a great semester. I learned a lot, and I'm sure the class feels the same way. I really hope to see you all in the future, and have a good one.